Well, welcome to MV Tutors. Well, if you'd like a session after this, then go ahead and comment asking for one, or alternatively, visit our website, which you will find under the description of this video, and book a session over there. Otherwise, today we're talking about trigonometry, compound and double-angled identities, because those are the ones they add in metric. Okay, so let's get right into it. Now, I like to start my session with a vision in mind to know what we are working towards. Now, this is our vision right here to answer this question here. As you can see, it's going to be 1, 2, 3 questions. If you don't know how to answer any of them, then stick around. Let's get right into it. And then hopefully at the end of this, you'll be able to tackle such questions. Okay, now let's start from the very basics, the definitions. Okay, definitions. All right, so say for example we have a triangle. All right, so let me just use a different pen for it, and maybe a pencil too. Okay, so there we go. I thought I chose it to be black, but red is fine. Okay, so we have a triangle right there. Good. Now, let's go back to our pen. Let's say our theta is there. There's our theta now. Theta, that's the opposite of theta. This is very important to know that everything is based on theta. So the opposite is actually the opposite of theta. So if theta is over there, then the opposite will be down here. But we're talking about this theta here. So the adjacent of that theta, of this theta, is there. And then the hypotenuse, which is the longest one, is there. So we know that sine theta we'll have to define. Okay. And we'll have to define cos theta as well. We also have to define tan theta. Now these are the very basics. What we use is what I call, or what we call, soccer, as in football, just the spelling is different. Soccer, Torah. Okay, now it's a weird word, so it makes it easier to remember because it's weird. So soccer, Torah, this S stands for sine, okay, and then this stands for opposite over hypotenuse. So we can go and put there opposite over hypotenuse. Okay, and then this, that's cosine, that's adjacent. So cosine is adjacent over hypotenuse. Okay, let's go ahead and write it. It's adjacent over hypotenuse. And then Torah, that's tan. That's opposite over adjacent. Okay, so tan is opposite over adjacent. Okay, so those are the very basics. Okay, we also have this thing, while we're still on the basics, that I call cast. Okay, so cast is cast, you write it like that in its quadrants. What this means is that cosine is positive in this quadrant. Okay, this is quadrant 1, that's quadrant 2, that's quadrant 3, that's quadrant 4. So cosine is positive on quadrant 4. All of them are positive on quadrant 1. Only sine is positive on quadrant 2. Only tan is positive quadrant 3. So those are the basics. Now let's talk about the reduction. What we call the reduction formulae. formulae. Now, what you have to know then is, if we go back to our Cartesian plane, that's theta there. Here, this quadrant is 180 minus theta. This one is 180 plus theta. This one is 360 minus theta. Okay. Also known as just minus theta as well. Okay, so what this says, there's a connection between this one and that one, because we can say sine 180 minus theta is equals to a positive sine theta. Okay, also because here, if we just include our cast here, let's say cast, just so that we know. Okay, so now what that means is that here 10, if we say 10 180 plus theta, then that's going to be equals to a positive 10 theta. Likewise here, if we say cos 360 minus theta, that's going to be just a cos theta positive. That's the only times when they are positive. So for example, if we say instead of sine, we put, say, maybe let's say cos 180 minus theta, that's going to be equals to a minus cos theta, because in this quadrant cos is actually negative. Even if we say sine 180 plus theta, the only one that's positive in this third quadrant is 10, so sine is going to be negative. Okay, and so on and so forth. Okay, so that's what we call the reduction formula. Let's talk now about special angles. Okay, so now for special angles, we're going to need a pencil. Let's draw a triangle. Okay, let's just draw a nice straight triangle like that. Okay, well, let's pretend it's closed there. No big deal. Okay, so what we say is that if you have 30 degrees, 30 degrees is a special angle. It means you have 60 there. That's 90 degrees. All right, how I like to remember is that where you have 30 degrees, you have a square root of 3, a 3 and 3, a 30 and a 3. They go together because both of them have 3 in them. Then this is going to be 1, and then this is going to be the square root of 2. So you have 1, 2, 3. That's how you put them together. Okay, so now what this means is that if you have sine of 30, sine, remember, is opposite over hypotenuse. Okay, so opposite of 30 is 1, and then the hypotenuse is square root of 3. Also, if you say sine of 60, sine is opposite over hypotenuse. Opposite of 60 is what? Square root of 3. Sorry. My bad. I made a mistake here. See, I'm making mistakes already, and we haven't even gone that far. This 2 here is not square rooted. Okay? And so the hypotenuse is not, it's supposed to be a positive 2. So it's 1, 2, and square root of 3. So 2. Don't be afraid to make mistakes, guys. You learn from mistakes a lot, and Once you've learned, don't make it again. You know what I'm saying? Just correct them and move on, like I'm doing right now. Okay, let's just do one more for control. So if we say then, let's use 10. Let's say 1030. Okay, 10 is taller, so it's opposite over adjacent. Okay, and the opposite of 30 is 1, and then the adjacent of 30 is a square root of 3. Okay, now this is not the only special triangle that we have. We also have a 45-degree one. Let's just look at that one real quick. Okay, I need my line straight. Okay, so let's do this. There we go. And then that's it. So this one, you have 45 degrees. Let's just go back to the pen. 45 degrees there, and then you also have a 45 there. You have a 90 there. Okay, and the numbers are 1, 1, and the square root of 2. So this means that cos of 45 is equals, cos is adjacent, so adjacent over hypotenuse. So adjacent of 45 is 1 over square root of 2. Let's do one more. Let's do 10 of 45, which is taller, opposite over adjacent. The opposite is 1 over adjacent 1, so final answer is just 1. Okay, so those are our special angles. Now I want us to speak about what we call co-ratios. Okay, so likewise, even this one, I want to start it with a triangle, because triangles, they do well to explain these concepts where you can see them. You can see these concepts in action. Okay, let's speak about co-ratios now. So with co-ratios, if you have theta over here, okay, then over there, actually let me do it around so that, because I have space down here. If I have theta there, that's theta there, and I have 90 degrees there, this angle here is 90 minus theta. This angle here, it's 90 minus theta. Now watch what happens carefully. If I say to you sine theta, okay, let's say that's A, that's B, that's C. Sine theta is opposite over hypotenuse. Now opposite of theta is B, and the hypotenuse is C. And then I say to you cos, what's cos 90 minus theta? Okay, there's the angle 90 minus theta down there. Now remember, cos is adjacent over hypotenuse. All right, so adjacent of this angle 90 minus theta, we have B, and the hypotenuse is still C. So can you see that these answers are actually the same? That is what we call a co-ratio. So now looking at a normal triangle, I mean a Cartesian plane. Okay, let's look at this. Sine 90 minus theta. Now let's start with the sine. 90 minus theta, that's 90 over there, it's 0 there, 90 there. 90 minus theta is in this quadrant, so sine in this quadrant is positive. Okay, therefore, and that's equals to cos theta. Okay, the 90 minus theta changes a sine into a cos, right? Just like we demonstrated on top there. if I say sine 90 plus theta, okay, first of all, it's in this quadrant. That's 90 plus theta is in this quadrant. It's on the second quadrant. So sine there, if you remember your cast, okay, sine is positive on that quadrant, okay, and then 90 plus theta changes a sine into a cosine. Okay, now let's look at cos 90 minus theta. 90 minus theta is on the first quadrant, so cos on the first quadrant is positive, and 90 minus theta changes a cos into a sine theta. And then finally we look at cos 90 plus theta. We start with the sine. Cos 90 plus theta is on the second quadrant, so is cos negative or positive in the second quadrant? It is negative. Then 90 plus theta changes a cos into a sine. Okay, so remember that you have to start with the sine before you change a cos into a sine or a sine into a cos. Okay, this is the only time though when the answer is negative. Okay, so those are identities, and then just one more special identity I want to bring into your mind. Sine squared theta plus cos squared theta is equals to 1. Okay, so this is more or less stuff you do in grade 11. That was just a quick revision. We're going to look at the grade 12 one just now. Okay, so let's now talk about the addition from grade 12, which is compound angles. Okay, the identities. Okay, so what you have to know here is what compound actually means. Okay, it means adding on top of another or under another one, because you can also subtract. So when we have cos alpha minus beta, the identity is such that you're going to have cos alpha, cos beta, and then watch the sign. The sign changes from a minus to a plus, and then you have sine alpha, sine beta. Okay, so now cos alpha plus beta, that's equals to the same cos alpha cos beta. Now check the sign, it changes from a positive to a negative. Sine alpha sine beta. Okay, so that's for cos. Let's deal with the sine now. Sine alpha minus beta, that one now is going to be equals to sine alpha, okay, cos beta. Now the sign, it changes from negative to negative again, so it doesn't change, it stays as it is for sine. And then this side you are going to have cos alpha sine beta. As you can see, it changes with what you start in. The order stays this way. In any case, this is going to be in your formula sheet. It should be in your formula sheet. Okay, it's given, so you don't have to remember this. Okay, so if you add them, you're gonna have sine alpha cos beta, and then a positive remains a positive, and then you interchange cos alpha sine beta. Okay, so that's what we call compound angles. Now let's deal with the double angle identities. Okay, so this is now the double angles. Double angle identity. So with double angles, it means twice. You guessed it. So the first one we're gonna deal with is sine 2 theta. Okay, so if you have sine 2 theta, then the double angle there is 2 sine theta cos theta. Okay, and then the other one is cos 2 theta. Now cos 2 theta is basically 1, but you can manipulate it in order for it to become three equal parts. So the basic one is that it is cos squared theta minus sine squared theta. And then the other one is also equals to 2, okay, cos squared theta minus 1. It's also equals to 1 minus 2 sine squared theta. Okay, well, if you want me to manipulate this, I can do it for you very easily. But for the purposes of this video, let's not do that because these formulas you are given in any case. Okay. Okay, so now we can do the question that we had in the beginning. We have all the tools that we need. Let's start with 5.2.1. So it says prove the identity above, and we've been given 8 sine 180 minus x, and then it's cos x minus 360. Okay, and then this is all divided by sine squared x minus sine squared 90 plus x. Okay, so what tools are we going to need? We're going to need our cast. Okay, so using the cast, we can get rid of the brackets. Okay, so 8 sine 180 minus x, that's in the second quadrant. It's here because 180 is there. So 180 minus is in this quadrant. So in this quadrant, sine is positive, so this remains positive. It just becomes sine x. Okay, and then we have cos x minus 360. So x is in this quadrant, and then minus 360, well, that's a revolution, so that's like going like this. Minus 360 gets you back there. So cos is actually positive as well, so it becomes cos x. Okay, now this one at the bottom, sine squared x, that one remains the same. We can't manipulate that any further. Minus this one, it's 90 plus. Okay, so 90 plus is in this quadrant. Sine is positive in 90 plus, so the sign remains as it is. It's negative, negative, so it's a positive, because sign is positive there. So because it's 90 plus, it changes to a cos squared x. Okay, let's manipulate further. Okay, now this, you can see it looks like a double angle identity, this one that we did over here. Okay, so we are basically moving from this side to that side. Depends on the question. Sometimes you're required to move forward, sometimes you're required to move backwards. In this case, we're moving backwards. So In order to make this a 2, it means we must take a 4 out, and then we must have a 2 sine x cos x. You see, now it looks like the identity itself. 2 sine theta cos theta. Okay, now let's go on. Now what we're going to do, we need to manipulate what's going on down here. Okay, so because it now depends on experience what you choose to actually manipulate. So based on experience, I know I have to manipulate this whole thing such that it becomes cos squared minus sine squared. Okay, so that I can also move likewise from this side to that side. So how am I going to manipulate this such that it does that? Let me rub this first. Okay, and then let's put the pen back on. So how I'm going to manipulate is that the cos has to be positive and then the sine has to be negative. So I'm going to take out a negative. Okay, and then once I do that, then the cos inside the brackets is actually going to be positive, and then the sine is going to be negative, like that. See what's happening? If I multiply this out and getting rid of the bracket, I go back to this, because minus times a cos gives you a minus cos, and a minus times a minus sine, it gives you a positive sign. So it goes back to that. This is just manipulation. Okay, now that we're done with that part, that 4 remains a 4. This, we already know, it's that identity. It's a double angle identity, so it becomes sine 2x. And then this one at the bottom, we have a minus there. It becomes, that's a cos 2x. Okay, now if you want to remember whether tan is sine over cos or cos over sine, you just go back to SOHCAHTOA, because you know that tan theta is equals to opposite over adjacent. So the one that has an opposite is a sine, and then the one that has an adjacent over hypotenuse is a cos. So tan is always sine over cos. So right here, what's this gonna be? It's gonna be minus 4 is equals to tan 2x, which is equals to the right hand side. Actually, in proving, you need to state which one you're starting with. So we started with the left hand side. Okay, and then we proved it. There, we are done. Now they say for which values of x in the interval up to 180 will the identity be undefined. Okay, so that's 5.2.2. So for something to be undefined, it has to be equals to 0. I mean, divided by 0. And this is undefined. So let's look for a fraction. We can see that we have a fraction over here. Okay, 10 is actually equals to minus 4 sine 2x over cos 2x. Now, in order, x can be anything. In order for us to get a 0 underneath, we need to say cos 2x has to be equals to 0. Okay, and then once we are done with that, we need to solve what x is. Okay, now if you remember, if you know your course graph is basically, let me just quickly do it. Course graph starts up there at 1. Let's say that's 1 and that's -1 up there. It starts there, comes down here, it crosses, and then it comes up and ends there. So it's 0 here, it's 90. Here it's 180. Here it's 270. And then here at the end it's 360. Okay, so those values there. So the course graph is 0 at 90. Okay, so 2x then has to be equals to 90. Okay, and then in order to solve for x, we have to divide both sides by 2 such that x becomes 45. Another place where 2x, the graph is equals to 0 at 270. Okay, so if we divide by 2, then we get 135. But now check this out. The question actually said in the interval 0 to 180. So that means that at 180 we cut right here, cut the graph right here. Anything this side, we disregard it. So the final answer then is x is 45 degrees. Okay, let's do 5.3 now. Getting the general solution. Determine the general solution of cos 2 theta plus 4 sine squared theta minus 5 sine theta minus 4, which is all equals to 0. Okay, so the first thing we have to do here is manipulate that. We have 3 identities for cos 2 theta, but because everything else is in sine, how we choose which one we use? We choose the one that's relevant. So the relevant one here, identity, is the sine one. So the sine one is 1 minus sine squared theta plus 4 sine squared theta minus 5 sine theta minus 4 is equals to 0. Okay, now we can simplify this further. We have a minus sine and then a 4 sine minus sine squared theta and a plus 4 sine squared theta. Those are like terms, so we can combine them. So minus, we will get 3 1 minus 1 plus 4 is 3 sine squared theta minus 5 sine theta, and then we have our numbers here. We have a 1, a minus 4, so then we'll have a minus 3. Okay, there's something going on here, something I missed here. What I missed here is this. This actually has a 2 there. Okay, this identity. So that means that my number there is not going to be the previous one. It's going to be minus 2 plus 4, where I get 2 theta. Now let's say, now I need to solve this. This is equals to 0. Now let's just, for argument's sake, let's say sine theta is equals to x. So we will have 2 sine squared theta, so that's x squared minus 5 x, because sine theta is x, minus 3. is equals to 0. So let's solve this equation. Now you can do this however way you want, but I'm just gonna go to a calculator. You can do this on your calculator as well. You can put it 2, and then we need an x, alpha. X is purple, so I got x, and it must be squared. Then I have a minus 5, and then I need an x again, minus 3, and then I put an equal sign. I need an equal sign. It's over there. It's purple. It's equals to 0. Then I need to solve. I go shift solve. So now I know that x is equals to minus 0.5, but also x is equals to 3. Now, when you look at a signed graph, it can never be equal to 3, because a signed graph is basically, if we're to look at a signed graph quickly, it starts from 1 and then to -1, and then it oscillates like that. Okay, so as you can see, the highest value is 1. Okay, 0.5 is still within, minus 0.5, it's still within, it's there, so it's within the graph parameters. Okay, 3 is outside, so x can never be 3. So then the only one that we're working with is x is equal to 0.5. Now let's remember, x we said is sine theta minus 0.5. From there, we can solve for theta. Let's get the reference angle, what we call the reference angle. And it's going to be equals to sine arc sine 0.5. Okay, now there's two methods, but the one that I prefer to do this one with is that the sign, the positive or negative, it's just telling you which quadrant it's in. Okay, now if you remember your cast, sine is positive in the second quadrant, so it's negative on the third and the fourth. Okay, so the answer we're looking for must be negative. Okay, the reference angle. Okay, so that's all. But when we come to the calculator, we always put a positive number there all the time. Okay, don't make the mistake of putting a negative one unless you're doing the other way of doing it, which I'm not going to teach you now. If you want me to teach it to you, you can book a session with us, and I'll be glad to teach you. So let's go. We need arc sine. Make sure you're in degree mode, 0.5. And we get our reference angle is 30. So this is equals to 30. Now, where does this help us? Now, it tells us that we have it's not a second, it's a third quadrant. So we're just going to say third quad. On the third quad, we know that the third quad is 180 plus theta. So we're going to say then our theta is equals to 180 plus our reference angle. Okay, our reference angle is 30. So we're going to say 30 plus 360K. This means that it repeats itself every 360. So this value, as the graph oscillates, it repeats itself every after 360 degrees. Okay, so 180 plus 30 is 210 plus 360K. Now K has to be an element of an integer. Okay, an integer, if you remember, it's whole numbers like 1, 2, 3, 60, 70, whole numbers like that. Okay, now just to complete it, We're also on the fourth quadrant. On the fourth quadrant, we have 360 minus theta. So our theta will be equals to 360 minus the reference angle, which is 30, plus K 360. Okay, so 360 minus 30, that's 330, plus 360K, where K is an element of an integer. Now, if you look at the graph again, that means minus 5 is there, so the value there, this is 210, and then that one there, also there, that's 330. Go up there. Okay, that's what it means. Those are your answers, and that's how you do it. Thank you very much.